Alright, so in this video I'm going to be talking about something called the dot product. Sometimes it's called the inner product or the scalar product, and how we use this to find the angle between two vectors. So as I have written here, the dot product, which has these other names, takes two vectors, so you multiply two vectors together, and it gives you back a number. And it's going to feel like a random number, and I'll explain in the second half of this video what that number is used for. But there's a formula for the dot product. It's incredibly simple. Suppose that you've got two vectors, and one of them is the vector A, B, C, and then dot. It's sometimes called a dot product because you put a dot in between. And the other vector is called X, Y, Z. And so those are the components. Like, I mean, these could be 1, 2, 3, and 4, 5, 6, whatever. To do the dot product, you simply multiply the X parts together. So that's A times X plus, then multiply the Y parts together. So B times Y plus multiply the Z components together, C times Z, and this sum right here, that is the dot product. Like, I mean, to be honest, it should be one of those things that seems like it's too easy to do. If somebody asked you to multiply two vectors, most people would just try and multiply the pieces together, and then if I just told you to add them up, you would have the dot product. That's what it is. And so I'm going to go into an example of that. Oh, by the way, if you only have two-dimensional ones, so like let's say you have, 3, 5, dot, -1, 4, great, you just do the first two parts of this. So this would be 3 times -1 plus 5 times 4. So that's -3 plus 20. Great, the dot product is 17. Right? So going on to this example I had planned. So in this problem, I'm giving you these 3 points, A, B, and C. Part A, I want you to find vectors A, B, and AC. So that those are, that should be reviewed. Like, I mean, everybody should be able to pause the video right now and do part A. So please pause and find A, B, and AC. So AB, we will find by doing OB minus OA. So first we write the position vector for OB, so that means 2, -1, 5, minus the position vector for OA is -1, 3, 2. And so when I subtract those, I'm going to end up with 3, -4, 3. So that's my first part for A. My second part, they wanted AC. Well, for AC, we're going to do OC minus OA this time. Well, OC is just the position vector for C. That means it's going to be 3, 0, 4. Minus the position vector for A, that's this one over here. That's the point, and we just write it as a vector. And when I subtract those, I end up with 4, -3, and 2. So that's part A. Part A just asks us to find those two vectors. Part B, and this is common for the IB exam, they'll have you do part A, and then part B will lead from that. Part B, they want you to do the dot product of those two vectors. So for part B, if they want me to do AB dot AC, well, we'll just take our two vectors, the two things we just found. 3, -4, 3, dot 4, -3, 2. And again, I mean, if you saw the formula on the previous page, you should be able to do this on your own. Pause the video, make sure you can do the arithmetic. So when you work this out, you're going to end up with, let's see here, 3 times 4 is going to be 12, plus -4 times -3 is also 12, and then plus 3 times 2 is 6. That ends up being 30. So the dot product of these two vectors is 30. Okay? Hopefully a pretty simple thing. So the next thing we move on to is, like, great, so we get this number, like, what does 30 have to do with these two vectors? And the reality is that the number that you get from the dot product is useful for finding the angle between two vectors. Right? So if a problem is a vector problem and it ever talks about finding the angle between two vectors, like, please use this formula. Like, if you see the words vector and angle in a problem, I pretty much guarantee you it's going to be this. Okay? There's a formula. The formula says that that number you got from the dot product is equal to the magnitude of the first vector times the magnitude of the second vector times the angle in between them. So if you have two vectors, you can find the dot product, you can find the magnitude of the first one, you can find the magnitude of the second one, and then you can plug them into this formula and use inverse cosine to solve it. Right? If you're feeling up to it, try this example on your own. If not, I'll do this one with you, and then there will be another one for you to try on your own. So if you want to find the angle between these vectors, remember I said if you're going to do that, use this formula. What you sort of have to do is you have to, I suppose you do it in steps. Step 1 is, what is the dot product? right? What is the first vector dot the second one? Well, the dot product of these vectors would be negative 3 times 12 plus 4 times 5. That means negative 36 plus 20. Okay, so my dot product is negative 16. That's not the answer to the question, but that's the dot product. The next thing we have to do is we have to compute the magnitude of that first vector. Right? So what is the magnitude of this vector? Well, it would be the square root of negative 3 squared, which is 9, plus 4 squared, which is 16. That ends up being the square root of 25, which is 5. The magnitude of b we do in the same way. This is the square root of 144 plus 25. Some of you may have recognized that as a Pythagorean triple. That ends up being 13. Right? So what we have here is we have our dot product, which is right here. We have our magnitudes, which are here. And so I can just plug this into the formula. I'm going to end up with negative 16 equals 5 times 13 times the cosine of the angle in between these two vectors. And so now I just kind of have to solve this thing. I'm going to end up with cosine theta is negative 16 over 5 times 13. If we plug this stuff into the calculator, let's see what we end up with. Okay, so I ended up getting that the cosine of the angle is going to be negative 0.246. So then when I did inverse cosine, by the way, when you do this, don't forget that the denominator has to be in parentheses when you punch into the calculator. I'll end up doing the inverse cosine of that. And when I do that, I end up with 104 degrees, or 1.82 radians. Right? So, you know, those are the two answers that would be acceptable. That's the angle between those two vectors. Okay. So I have an example now that refers back to the first example that we did, where we found some vectors, right? I'm giving you 3 points, the same 3 points that we worked with earlier, and I'm asking you to find the measure of angle BAC. And this is a really important thing, so make sure you've got your brain turned on for this. Think about what angle BAC looks like. BAC, and it doesn't even have to be accurate. If this is B, and this is A, and this is C, a lot of people make the mistake of, like, they see it's an angle question, and they get that it's a vector problem, but then they go, oh cool, I'll use vector BA and vector AC. And that doesn't work. If you draw a picture of BAC, you'll see that the vectors you need to use are AB and AC. It's very important that you get that idea right. So if I were to ask you to find the angle XYZ, well, that means there's an X and a Y and a Z. You would want to use vectors YX and YZ. Okay, so coming back to our problem, if they want us to find BAC, we need to have vectors AB and we need to have AC. Right? If only we knew what those vectors were. But we do. We did that in the earlier problem. I don't even have to show work for that. We did that earlier. AB was 3, negative 4, 3. AC was 4, negative 3, 2. Right? At this point, you have two vectors. You guys all should be able to find the angle between these by using the formula on the previous page. We know that the dot product of two vectors is supposed to be equal to the magnitude of the first one times the magnitude of the second one times the cosine of the angle between them. So pause the video, compute that dot product, compute the magnitudes, go through these things and make sure that you're getting this answer. Alright, so the dot product of these two things, in fact, we even did that on the earlier part. We found out that that was 30, right? The magnitude of AB is the square root of 34. The magnitude of AC is the square root of 29. And then we have cosine theta. To solve for cosine theta, I'm going to move those roots over. So this will be 30 over... And I do something interesting here. I actually put the 34 and the 29 together inside of a root. The reason I do that is it makes the calculator easier. Because in the calculator you'll do 30 divided by square root, and the square root will sort of automatically come with parentheses, and that way you won't make a mistake on that. So now I'll punch this stuff into the calculator and see what we get. So I ended up here with, cosine theta is 0.955. So when we do the inverse cosine of that, let's see here, I ended up with 17.2 degrees, or 0.2 0.99. It actually rounds up to 0.300 radians. Right? So that is the angle between these two given vectors. I do have one more really important part of this video. I know this is going long, but this is a really important one coming up, so if you need to, pause and take a screen break, come back, but this is a big one. I put it in all caps so that you would see it. So first, the special note. If two vectors are perpendicular, then the dot product of those two vectors will be 0. And that actually makes sense. If you think about the formula says A dot B is equal to magnitude A times magnitude B times the cosine of theta. What happens if theta is a 90-degree angle? What happens if they are perpendicular? Well, we know the cosine of 90 degrees is 0, which means you would have the dot product being 0. And so the conclusion here, if you see a vector problem and the word perpendicular shows up at all, you will take the dot product and set it equal to 0. Okay, so I have one example of this for us. I want us to find the values of the constant k such that the following vectors are perpendicular. Looks like I forgot to write them down, but hopefully I have them set aside over here. The two vectors I wanted us to use are the vectors 2, 3k, and the other vector is 5, k minus 2, and k plus 2. So the idea is you're given these two vectors. These vectors are supposed to be perpendicular to one another, and we need to find the value of k that causes that to happen. So I mentioned before, we take the dot product, we set it equal to 0. So what is this dot product? Well, the first two terms, the 2 and the 5, will multiply together to give me 10. The second two terms, we can sort of multiply to get 3 times k minus 2. And the last two terms will multiply to give me k times k plus 2. And because they're perpendicular, we expect this to be 0. Right? So now I'm going to go through and simplify this. Right? I've got 10 plus 3k minus 6 plus k squared plus 2k equals 0. And here we have a quadratic that we can hopefully solve. If I bring like terms together, I'll get k squared plus 5k plus 4 equals 0. This factors really nicely as k plus 4 times k plus 1 equals 0, which means there are two values of k. K could be negative 4 or k could be negative 1. Either one of these would lead us to two vectors that are perpendicular to one another. Hope that makes sense, and good luck with the practice.